Hi friends, last video we see what is the idea background of the Lagrange multiplier method. Now first we summarize what is the Lagrange multiplier method. Next we see one example. To find the so our main is my objective function is f of x comma y comma z with constraint g of n. First we want to find the gradient of f times equal to lambda times gradient of g and solve those equation. We get set of all points. Those points we consider as a critical point in our, it's not exactly critical points, but we previously we studied that is a critical point. Those points only we want to check it what is the maximum and the minimum of this function. That is the second step set. Evaluate all the points, which among the which is the maximum, that is the maximum value of the given function f with the subject to the constraint, and which is the among the smallest f, that is called smallest minimum of the given function subject to the constraint. Now we see one example. Suppose I have a rectangular box without lid, that means one side is open, made from the 12 meters square of the cardboard. Find the minimum value of, so find the maximum value of a box, maximum volume of a such a box. Okay, so first I want to define what is my objective function. So they told that find the maximum value of the, find the maximum value of the maximum volume of a function box. So volume of a box is rectangular box is volume is I denoted as V is function of x times y times z. Here x is a length, y is a breadth, and z is the height. I know. Now, but they will make that uh, only you have the 12 meter square cardboard. So you have the subject to the constraint. What is your subject to the constraint is, that is your surface area. Surface area is one side is box is open. So your surface area is 2 times xy plus 2 times yz plus one side is open. I will take it, that is the one side x comma z, x times z equal to 2r. So this is my objective function. This is my constraint. How I can solve? First step, what is the Lagrange multiplier say? First you want to find the gradient of given v. What is gradient of v is and equal to lambda times. So we'll take it as gradient of v. So I will take it, this is some s equal to some lambda times gradient of s. So what I will get it? First step. So first step, x yz equal to lambda times 2y plus ez. Correct, because I want to take the positive derivative with about x, so it's become only z only comes. Second step I will get it, xz equal to lambda times 2 times x plus 2ez. Suppose I want to take the positive derivative with respect to ez, that will become x times y equal to lambda times 2y plus 2x. So I will take it, this is my equation number 1, this is my equation number 2, this is my equation number 3. With the constraint is 2x plus 2xy plus 2yz plus xz equal to 2y. So this is my equation number 4. So I have the 4 equation, I want to solve it. Okay, the first equation, to solve I first equation multiply by small x. This implies xy z equal to lambda times 2xy plus xz. So now I'll take this is, and the second is Second equation is multiplied by y. This implies xyz equal to lambda times 2xy plus 2yz. So third equation multiply clearly z, that is xyz equal to lambda times 2yz plus, so here only x only will come because I want to take the derivative with respect to z, simply x only will come. Okay, so here xz, now it's coming. So this is equation number, namely I will take it equation number 5, this is equation number 6 and equation number 7. So left hand sides are x comma y are equal, so 5 and 6 are equal, the right hand side. So it implies, so I cannot assume that lambda equal to, I say I can, what will happen if I equal, say lambda is here some constant, so lambda is equal to 0, what implies x times y times z equal to 0 from the equation number 5 or 6 or 7, anytime, anything. This implies, so one of the guy is x times y times equal to 0. So it does not have the any, the trivial solution only gives that x equal to 0 or y equal to 0 or z equal to 0. It does not contains any volume. So it is meaningless way we will comes. Okay. And further, so to avoid that, I will take it as the lambda equal to, lambda is not equal to 0. This implies lambda times 2xy plus xz equal to 2 times xy plus 2 times yz from 5 and 6, from 5 and 6 equation. So I know that this guy we can cancel, this implies, and x, this implies xz equal to 2 times yz. So z will cancel, this implies x equal to 2 times y